Okay, good afternoon. I'm not sure if anyone is here yet, but if you are, you can just type in the chat. So, good afternoon, students. And today's live will be focusing on Unit 2 Cape Geography. So, today we're looking at Unit 2 Cape Geography. So, if you are there, you can just type in the chat box so that I can see that you are here and you can interact with me because I don't like talking to screens, right? Nobody like to feel like they're talking to themselves. So thanks for joining me. Thanks for joining me. And my students are really the ones that are behind me to do the CAPE Unit 2 revision, right? Hi, Chelsea. Chelsea, good afternoon. Today we are doing a CAPE session, so I'm not too sure if this will be applicable to you. It is for CAPE geography. So I'm not too sure if you are CSEC geography. I think you're CSEC, right? So this may not be applicable to you. So if it's not, you can come off unless you want to stay and see what CAPE geography is like. Um, so I am just waiting for some more students to come on to the live session today. That's okay. That's okay. I know I know you probably saw the live notification and came on. So it's okay because I've been only doing CSEC classes so far. But today I am doing CAPE Unit 2 Geography. So if you are here for Unit 2 Geography, hi, Calicia. So today's class, maybe I should just put this. Oh, thank you, Chelsea. What school do you attend? Thanks for your feedback. I really appreciate that you are enjoying classes and faith. It's nice to have you all. But today's class, I'm going to put it in the chat, is for CAPE Unit 2 students. Good afternoon, Gabriel Brown Lambert. So I'm seeing all of my regular CSEC students are here, and it's nice to see you all. But today I am doing CAPE, which is Upper 6 Geography. So I'm doing CAPE Unit 2 today because my students asking me for these classes. He said, Miss, you're only doing CSEC. Are you going to do CAPE? So I am doing CAPE today. And thanks you, Chelsea. I'm glad that you are enjoying the classes. Chamaya Vidyala. Chelsea, what school is that you go to? Are you from Trinidad and Tobago? I'm thinking yes. Faith, is nice to see you as well, Gabriel. But today's class is for CAPE Unit 2 students. So if you are in CAPE Unit 2 and you are here, just drop a little hello in the chat so that I know that you all are here and I can continue on with the live. Nice to see you all, but we will do another session next week, please God, for CSEC. I have some more past papers. Oh, it's a private school. Really cool. Nice. Chanamaya Vidyala. Okay. First time I heard about the school, but I'm glad that you are enjoying classes, Chelsea. That's good to hear. So make sure you share the page with your friends, the School of Geography page on Facebook and YouTube. Make sure that you subscribe and you hit the notification bell so you get all of the notifications when I go live. So it's now 10 past 5, and I will continue with my class for today. It is Unit 2, so let's get into it. So, CAPE Unit 2 Geography focuses on three main three modules, right? So you have, of course, your map work section, and then you have module 1, you have module 2, and then you have module 3. So module 1 is climate, vegetation, and soils. Module 2 is economic activity in terms of agriculture, industry, and tourism. And then module 3 focuses on development and disparities. So for today, I'm just going to share some tips and approach to how to start studying for the CAPE Unit 2 exam, and also we can get to some past paper questions. So some important things before we start, let me just load up all the things that I have to share here today. Right? So I am not too sure if you all noticed, but the okay, I'm trying to get these things up and going here. All right, great. So let me know what you are seeing on the screen. Now it should be on the topics that were released for the CAPE Unit 2 examination. Are you all able to see the topic at all, or is it very small? Oh, sorry, I was speaking. I guess um, you wasn't hearing me. Sorry, because I took myself off of the screen. I'm sorry about that. Okay, so I have up the syllabus here, and what I was really saying to you all is that for the broad topics that they gave you all, it's more like a sort of a coax. They really didn't give you all much hints with respect to what will be coming on the exam. So if you really look at the syllabus, the outline of the syllabus in terms of weather system covers all of these things here. So you would see global surface and upper wind circulation, including jet streams. So from objective one all the way to 10, right? All the way to actually 12, objective 1 to 12. All of that you have to study for the exam. So there is no real hints that they give you. This is really broad. They can take question from anywhere. The next um, topic that they gave you all under the broad topic was vegetation, right? Vegetation types. And if you go to the syllabus again, under vegetation types, you would see it is everything under vegetation, which is from objective 1 to objective 5. And then if you go to soil formation and soil conservation, it is everything from 1 to 6. So practically you're studying all of module 1 for your exam. You all understand that? So you really don't have much leeway to say that you have hints. For module 2, economic activity, they did not say economic structure. So, okay, you can omit that. But from objective 2, where you have agriculture, you have to learn everything from 1 to 7, industry, everything from 1 to 6, because again, they told you agriculture, industry, and tourism, practically all of the module again, right? So industry and then tourism is 1 to 6. So you basically studying all of that. When you go to module 3, you're gonna have to study all of module 3 except for the first section that says development and underdevelopment. They didn't focus on that, but they did focus on global disparities. So, global disparities, you are covering again everything under global disparities from 1 to 5. There is no regional disparity, so you omit that, and then you're going to study everything from local disparities 1 to 3, and then measures to overcome disparities, which again is 1 to 3. So practically, you really don't have a lot of room to say that you are choosing specific objectives in this particular exam. The broad topics are too broad, right? So you have to study all of that. So how do you study? You look at your syllabus, you go under the specific objectives and see where they ask you. You would see that it says students should be able to explain the factors associated with the receipt of solar radiation, explain the factors influencing atmospheric circulation, and so forth, right? So you get those specific objectives and you study them under the different modules, under the different topics that they gave. Another thing that I really want to highlight that you all should also be preparing for the exam is you should at least have a copy of a study guide at this point, because if you have a study guide, it's going to make the studying process a bit easier. So I use the CXC, I think it's the CXC study guide, and you all should have that digitally. I'm not too sure if you'll have that digitally, but I can try to share that now. So are you all seeing the study guide? So if you have a study guide, it's going to make preparing for the exam easier. And then, of course, you have a textbook that you use. The one that we use in school, it is the textbook that we use in school. So this is a study guide, and the textbook that we use in school is the New Integrated Geography by Sheldon Blessdell. So this is a book, right? So you use this particular textbook to study along with the study guide, and that should help you, right? So you have to study smart. And at this point, you have to look at the question paper and study all of the questions that would come under climate, vegetation, soils. So for today's live, I think I'm just going to focus on questions that are climate related so that we kind of streamline how we do things. We don't do a whole paper, but we pick out the climate questions from different past papers and focus on those today. So let me know if that is okay. Another thing that is important to do, I'm not too sure if you all ever heard about the reviews. So the review, the CAPE reviews, right? It actually gives you everything, all of the reports for the previous years, right? So for all of the exams that would have gone already, you have those reports, and the reports give you some really good answers. So we have a report here. I'm not too sure if you all are seeing, right? But if you notice here, it tells you some of the answers or gives you some of the answer on how to answer the relevant question. So I think you can go to www.cxc.org, the website, go to the website, download the CAPE reports, right? I think it's CSEC specimen paper, syllabus, and reports. Download it, and that should really help you answer some of the questions. So let us go into it. We're going to start with 2019. We're focusing on climate related questions, and then we're going to go into 2018. So 2019, you all should be able to see 2019 now. Are you all seeing 2019 on the screen? Okay, so 2019, and the first portion of it, they didn't really give you a question is not going to be coming on map work, but you still have to be able to identify the patterns because it can still come in the first part of the question. Thanks, Daniela. So you would see this particular map. Can you all see it? So the first climate question is this map. Are you seeing the map? So on the map, the first question is name the weather phenomenon shown at X. So if you look at X, what is that weather phenomenon that you see? So you have to know your weather symbols, very important for the topic of weather, right? When you are looking at weather, you have to learn all of your symbols to be able to answer these questions, the interpretation question to the top. So, what is X? X is what system is X, or what feature is X, as they said there. I need you all to type the answer in the chat for me, please. So this is called a synoptic chart, and you have to be able to read the symbols and to be able to identify what the system are. So it's a front, but what type of front? You have to be able to tell exactly what type of front it is. Rashonda and Ayola, are you all there? Please. So yes, it is a front, but what type of front? These sessions can only be beneficial if you all are replying, right? Because I can talk to myself. Right, so it is a cold front. How can you tell the difference between a cold front and a warm front? What is the difference between the warm front and the cold front? How do you tell the difference? The difference is along the line, one is triangle. So we're seeing the triangles, and we know that the triangle is a cold front, and the circular um, symbols on the front would indicate a warm front. So yes, it's a front, but it is a cold front. Everybody understand that? The second part of the question asks, what direction is the weather phenomena at X traveling? So what direction is the weather phenomena traveling? What direction? Are you all seeing clearly? What direction is it traveling? So because this is a cold front, what direction will it travel? Cold fronts come from where? Cold fronts come from where? Okay, very good, Rashonda. Right? It's not going to be southeast. It's going to be, it is actually going to be southwest. Why it's going to be southwest? Where do cold fronts come from, Ayola? When you are looking at the map, this is a map of the Caribbean, right? So remember, if this is a map of the Caribbean, you can see where Trinidad and Tobago is located, and then you see the entire Caribbean, and then of course you see Central America, you know, North America, you know, South America the Caribbean is between those two. Of course, cold fronts come from up north in the polar areas, the areas that experience winters, and then it's going to travel down south, right, to us. So it is generally moving in this southwest direction. Everybody understands that? So you understand how you have to interpret this? It's in a southwesterly direction. So you can know the answers. The other question says to describe the weather condition at X and describe the weather condition at Y and at Z. So you're looking at Y and then you look at Z. So let us look at Y. So this is here. So you have the symbol. So you're going to see that with the symbols at Y, you have a number, you have a circle that's shaded, you have the the little line that you should know what that is, and a little symbol below. So again, if you don't know the symbols yet, I think even in your Form 5 textbooks would have gone through symbols, right? So it is not the first time you're seeing these things. So if you are to describe it, you are describing all of those elements that make up the weather station. So you're going to have to give your wind direction, your wind speed, the temperature, the cloud cover, and whatever little symbol is that. Is it in terms of, is it a cloud type, right? Cloud type. So can you all type in that for me? What is the description for the symbol, the weather station at Y? Put your answers in the chat. The description of the weather station at Y and at Z. So when you're telling wind speed, what is the actual each letter stroke is how much knots? It's easier to use knots because knot is an easy number to remember. So don't go and use kilometers per hour because or speed per hour. That is going to give you some problems. Yes, I can zoom in. I'm gonna have to stop. Yes. So y is 15 knots. Um, Rashonda, I'm not too sure if you were saying that each stroke is 10, but remember with wind speed, you have a short stroke and a long stroke. So the short stroke is 5 and the long stroke is 10. So that is how you get 15. You understand that? So look at it there. Is it a bit clearer here? The long stroke would be 10 and the short stroke would be 5, which is 15 knots. But what are the other elements? You have to describe the other elements. So give me the description in the chat of the weather station at Y. I want the full thing. Don't just give me one one aspect of the at the weather station. Give me all of it together. Daniela, is this familiar to you? Daniela, you can also put your description in the box to me. Is this familiar to you? Okay, so what book do you all use in school, Daniela? Can you tell me what book do you all use in school? If you all use this Blaisdell, the New Integrated Geography by Sheldon Blaisdell, the weather symbols is on page 76 and 77. And you have to know the symbols, at least the basic ones, like cloud cover. How do you tell cloud cover? Cloud cover is in eighths. So you have to remember that cloud cover is in eighths, right? So when you see distortion, you should know how much that is. So it is divided into eighths, right? And then, of course, the number is usually temperature. So very good, Ayola. Small cumulus clouds, right? You have a quarter cloud cover, right? A quarter cloud cover, the temperature of 30 degrees, wind direction. Don't forget to state wind direction when you are also saying the speed. So wind speed is 15 knots, moving in what direction? At the weather station Y, their wind speeds are 50 knots, blowing in a south easterly direction. The temperature is 30 degrees and consists of one quarter cloud cover, cumulus cloud, small cumulus cloud. Excellent. Excellent, Rashonda. Right? And Ayula. Good job. So now let us move to Y. Sorry, Z. To Z. So in your Sheldon Blaisdell New Integrated Geography, the symbol for weather system starts on page 75 and 76 and 77, right? So you could record that. If you don't have this book, whatever book you're using in school, I'm sure they're gonna have some sort of weather system, weather symbols for synoptic charts on there. So this one should be easier to do. Let me see your comments in the chat. Can you all see it, or you all want me to zoom in a bit more? Okay, I want to see your comments. The rest of you all that are online, I can see you all. Give it an attempt. Give it an attempt. This is very good. At Z, there is 1/8 cloud cover, a wind speed of 20 knots. Remember to state the unit Sayola in the exam, because people wouldn't know if it is kilometers per hour, right, or miles per hour. So make sure that you state that the wind speed, and it is in northwesterly direction with a temperature of 12. That is excellent, right? So that is the synoptic chart. So then they're going to ask you, we're going on to some more weather questions. And the weather question that they have here, what is the difference between an adiabatic? The first question in the module on the weather system is distinguish between an adiabatic lapse rate and an environmental lapse rate. This is like the basics, right? The basic in terms of looking at lapse rate, because what is a lapse rate? Do you all know what is a lapse rate? Can you all, anybody remember what is a lapse rate? When we look at lapse rate, it helps us to understand the conditions of stability and instability. What do we mean by stability and instability? Anybody know? Okay, so let us start with the definition of a lapse rate, right? So the lapse rate is the rate at which temperature changes with height in the atmosphere. So let us start with a definition. The lapse rate is the rate at which temperature changes with height in the atmosphere. So that is what a lapse rate is, right? The lapse rate itself can be positive, and that is where you have a temperature decrease with height. So, Ayola, where you talk about there's a fluctuation with temperature, I think that is what you're trying to say, because the lapse rate can be positive or it can be negative. Positive in that temperature, as you go higher into the atmosphere, it is going to decrease, right? Conversely, temperature can also increase in height, and that happens when we have a temperature inversion. Do you all understand that? So, with lapse rates, the environmental lapse rate, and you can also have the adiabatic lapse rate. And an adiabatic lapse rate consists of two main types of lapse rate. So I hope you all are writing at the same time, right? You have what we say is a dry adiabatic lapse rate or a saturated adiabatic lapse rate. So the dry adiabatic lapse rate is what we have, or what we call a DALR, and a saturated adiabatic lapse rate is what they refer to as an SALR. So now you have to distinguish between the environmental lapse rate and the adiabatic lapse rate. What do you think this means? When air becomes cooler than the surrounding air. Which one is that? Remember, the question is to explain, sorry, not explain. The question is to distinguish between adiabatic lapse rate and the environmental lapse rate. Are you all seeing that there? So distinguish between the environmental lapse rate and the adiabatic lapse rate. Okay, sure. So the environmental lapse rate, are you all seeing on the screen? The environmental lapse rate, good Daniela, when it increases every 1,000 meters, the temperature decreases by 6.5 degrees. So you would see here adiabatic lapse rate has to do with the change in elevation. So adiabatic lapse rate, let us look at it here. So the environmental lapse rate, I'm not too sure if you all can see the screen, right? Is the rate, actual rate at which ambient temperature changes with height. The environmental lapse rate is the actual rate at which the ambient temperature changes with height. So all this is saying it is the decrease in temperature in still air, right? With an increase in height through the troposphere. And it is approximately 6.5 degrees, right? There is a decrease in temperature by approximately 6.5 degrees per 1,000 meters. Everybody understand the environmental lapse rate? I'm not too sure if you all are able to see that. Or it may be a little bit too small. So that is the environmental lapse rate, right? The adiabatic lapse rate, on the other hand, it is used to explain, or it occurs as a parcel of air rises, right? It decreases in pressure and temperature, but it increases in volume. And the conditions can be reversed if the parcel of air move towards Earth, meaning there can be a temperature inversion. So the adiabatic lapse rate can be both dry adiabatic or it can be saturated. So the adiabatic lapse rate here, right? I'm not too sure if you can see it here. So the adiabatic lapse rate, you would see here, if there's no exchange with the surrounding air during the process, we call this adiabatic lapse rate, right? Adiabatic cooling. The rate at which air cools, we say that is the adiabatic lapse rate, right? The rate at which air cools, we call that the adiabatic lapse rate. An adiabatic lapse rate is a constant, whereas the environmental lapse rate, that is the decrease in temperature, right, with with an increase in height. So the environmental lapse rate is the decrease in temperature with an increase in height, whereas the adiabatic lapse rate, right, is the rate at which air cools. And you can have this being a dry adiabatic lapse rate and a saturated adiabatic lapse rate. The difference is that a dry adiabatic lapse rate, right, is where that dry adiabatic lapse rate is where is where the parcel of air is unsaturated, and it actually decreases at 3 degrees Celsius per 1,000 feet, right? Whereas the saturated adiabatic lapse rate is where the air parcel actually reaches dew point, and dew point means that it becomes saturated. So when you have condensation taking place in the atmosphere, right, you remember condensation creates that water vapor, which results in saturation. So all it's saying is when this unsaturated or dry air mass reaches saturation point, or it reaches dew point where it becomes saturated and it now becomes wet, right? Latent heat is released during this condensation process, and now we refer to that as the saturated adiabatic lapse rate, and that cooling is different. So with the dry adiabatic lapse rate, you see the rate at which an unsaturated parcel of air cools as it rises or warm as it descends is 9.8 degrees per 1,000 meters. And you would notice that that is actually um, higher than the environmental lapse rate. And then you have the saturated adiabatic lapse rate, which is lower because it is, of course, wet. So it's at cooler temperature. So you would see the rate at which the rate at which the fall in air temperature by adiabatic change as saturation gains altitude is 5.4 degrees per 1,000 meter, right? It is less than the DALR, so it is less than the dry adiabatic lapse rate because latent heat is released during the condensation process. So you need to remember adiabatic lapse rate is the rate at which air cools, right? It can be dry and it can be wet. For the dry adiabatic lapse rate, that is the unsaturated parcel of air, right? And that cools at a height, at a rate of 9.8 degrees per 1,000 meter, whereas when it reaches dew point, as it rises and it reaches dew point, it becomes saturated and it turns into this wet or saturated air mass now, which we call a saturated adiabatic lapse rate, which cools right at saturation of 5.4 degrees per 1,000 meter, and the saturated adiabatic lapse rate is always lower than the dry adiabatic, of course, because it is cooler. Everybody understands the difference now between environmental lapse rate and adiabatic lapse rate, and the two types of adiabatic lapse rates. Do you all understand that? Do you all understand that? Okay, good. The next question right? This is the last question I'm going to do because I have to attend something now. Let me share the question. Good. The next question talks about anabatic and katabatic winds occurring in mountainous region. And it says, write an essay discussing why anabatic and katabatic winds occur in mountainous region. Include a well labeled diagram. So this question um, is an essay question and they want you to draw diagrams. So the first thing you need to know is where this comes from. So this comes from microclimates, right? Because microclimates is that specific um, weather conditions or climate of a specific area due to its condition. In this case, what would create this microclimate is the mountain, and the mountain here is what governs these anabatic and katabatic winds. So I'm not too sure if you all use the new integrated geography. If you do, right, the diagrams for anabatic and katabatic winds is on page 122 with the descriptions. So I'm going to show it to you here. Can you all see that? So on in this book, it is page 122. You can go to the book if you have it, and it gives you all the diagrams, right? So anybody have an idea what is anabatic and katabatic winds? Just tell me if you have an idea what is anabatic and what is katabatic winds. What is anabatic? So the anabatic is what we call day winds, and the katabatic is what we call night winds. So just remember in the day what happens. In the day, you experience more insulation coming into the atmosphere, heating up of the atmosphere. So you're going to have very hot conditions, right? What happened, of course, warm air rises because the atmosphere is now warmer in the day. The opposite happens at night. So katabatic happens at night. It is just like land and sea breezes. You know, in the day, how the atmosphere is very warm, land and sea breezes, and of course at the night it becomes cooler. So katabatic, right, in the night, of course, what happened, the atmosphere becomes cooler and you have sinking of the air mass, right? So you have temperature inversions. So with katabatic, day winds, right? Anabatic, day winds, what you have is updrafts of the warming of the air. And because you have sunny, hot conditions that warm the atmosphere, that cause the winds to blow up the valley sides. So in the night, the winds blow up the valley sides, and that is what we refer to as anabatic winds. The opposite takes place at night. At night, you have now clear sky, radiation is lost from the radiation is lost because of the the latent heat being released again, and you have now cold, dense air that sinks down into the valleys, right? Or they sinks down the sides of the mountains under the influence of gravity, and it creates fog and frost in the valley or in the bottom of valleys, and they create what we call temperature inversions, right? And that is where, of course, the temperature now, it doesn't increase, but it increase, right? So that is the difference, the main difference between anabatic and katabatic winds, and you have to learn to draw the diagram. Do you all understand that? Let me know if you all understand the difference between anabatic and katabatic winds, please. Okay, excellent. So let me just show you all um, a quick diagram here that you can probably learn to draw. It's in your textbook, the new integrated. I don't know if you'll use that, but that is a very good book, right? Um, Let me see if I can share. Are you seeing it here? So you see anabatic winds. So anabatic winds, you see, during the day, these are upslope winds driven by warmer surface temperatures on a mountain slope than the surrounding air column, which causes air to rise. And then you have katabatic winds during the night. These are down winds, right? Down slope winds driven by colder surface temperatures on a mountain slope. So all you need to do is draw a mountain, draw, of course, the arrows of the winds going down into the valley for katabatic, and then for anabatic, you're gonna draw the winds going up the slopes of the mountain. Everybody understand that? Do you all understand that now? Okay, so I hope that this was helpful. We can try to do some more sessions next week where we go through some more climate questions, um, and go through the reviews. I hope this was helpful today. Was it helpful? Did you learn anything? Put in the chat one thing that you learned today, or one thing that you didn't know before that you learned today. Okay, great. So next week, please God, we will continue with some more questions on climate. And I want you all to do some revision so that we can move a bit faster, right? So one thing that you've learned today. Okay, so I have to run now. I hope you'll have a good afternoon, and the live session will be up on the YouTube channel, so you can tell your classmates or friends or anybody that needs help with Unit 2 climates that they can check it out. Have a good evening. Bye.